for the next example, you are given fx, x from negative pi until 0. Fx is equal to negative x from 0 until 2 pi, whereby your periodic function is fx plus 2 pi. So from here, our 2L is equal to 2 pi. So therefore, our L is equal to pi. So another method to determine the value of L, from the highest limit here, our L is equal to pi. So question 1 Roman, sketch the graph for the given function within the range negative 3 pi until 3 pi. So you have to expand your original graph, which is original graph from negative pi until pi. You have to expand to the negative 3 pi until 3 pi. So this is the answer for the 1 Roman. Your original graph from negative pi until pi. So you are given the function in terms of variable x, so means that you have to find the coordinate. So in order to find the coordinate, you have to make a table, which is you have x and then you have the fx, and then this is your coordinate. So x here refer for your limit, fx here refer for your equation that you have to find. So for here, your equation is fx equal to x from negative pi until 0, and then fx equal to negative x from 0 until pi. Then you have to plot your graph according to the coordinate that you have obtained. So this is the original graph for the negative pi until pi, and then you have to expand your original graph to the 3 pi on the right hand side, and then to the negative 3 pi to the left hand side. For the question 2 Roman, from 1, determine whether it is an odd, even or neither function. So based on this graph, refer to your original graph. In the dotted line here, we have the pattern slope on the left hand side and then the pattern slope on the right hand side. So this is our mirror. So the pattern on the left hand side is transposed to the right hand side. So this one is an even function because the graph is symmetric at y axis. For the question 3 Roman, find its Fourier series expansion. So this is the formula for the Fourier series expansion, whereby you have to calculate the value for the a0, an and bn. So since we know that our graph is an even function, so you have to calculate the value of a0, an by using this formula, and our bn we can directly write as bn equal to 0. So we can save our time whereby we don't have to calculate the value for the bn here. But if you want to calculate by using the formula of the neither function, there is no problem. But then you have to calculate for a0, an and bn. If we use the even function here, the formula for the even function, we only have to calculate for the a0 and an, whereby the bn here, we can just write bn equal to 0. So the formula for the a0 and an here, it is 2 over L, and we integrate from 0 until L. Why we integrate from 0 until L? Because the graph here is the same pattern. So that's why we have to calculate 2 over L, integrate from 0 until L, whereby from 0 until L, our L is equal to pi, and then we multiply with 2. Instead of integrate for both sides, we only integrate for one side. So now we want to find the Fourier series expansion. In order to find the Fourier series expansion, you have to calculate for the a0, an and bn. So since our graph is an even function, so our bn is equal to 0. So we can directly write as bn is equal to 0. So now we have to calculate for the a0. So formula for the a0 is 2 over L, integrate from 0 until L, fx dx. So our L is equal to pi. So now we substitute the value of L and our fx into the formula here. So L is equal to pi. 2 over pi, integrate from 0 until pi. So we want to integrate from 0 until pi, so you have to refer to the limit whereby you have 0 until pi. So the first limit here, fx equal to x, our limit is from negative pi until 0. So for the second function, fx equal to negative x, our limit from 0 until pi. So now you have to substitute your fx according to the limit that you want to integrate. So your fx here is equal to negative x. Why negative x? Because we want to integrate from 0 until pi. Okay, now we want to integrate negative x. So integrate negative x will become 2 over pi negative x the power of 2 divided with 2. And your limit from 0 until pi. So now substitute the given limit. Substitute pi to the position of x. 2 over pi negative pi square divide with 2 minus. Substitute 0 to the position of x. So 0 divided with 2 will become 0. And now you have to simplify. 2 over pi multiply with the negative pi square over 2. So we can cancel out the pi, and we can cancel out the pi at the bottom side and pi the power of 2 at the upper side. So cancel out the 2, cancel out the pi. Our a0 is equal to negative pi. So now calculate for the an is equal to 2 over L integrate from 0 until L, fx multiply with the cos. So your L is equal to pi. So we have to substitute the value of L. An is equal to 2 over pi integrate from 0 until pi. The same thing, you have to refer to the limit here. You want to integrate from 0 until pi. The given function for the 0 until pi is fx is equal to the negative x. So we substitute fx become negative x. Negative x multiply with the cos and pi x over L. So you have to substitute your L here become pi. Cos and pi x over pi. So before you want to integrate, the cos and pi x over pi here, in the same argument you have pi divided with pi. So we can cancel out the pi. So we write back 2 over pi, integrate 0 until pi negative x, cos and pi x divided with pi. So since we have cancelled out the pi, the things that remain here is an x. By using tabular method, we have to integrate negative x multiply with the cos and x. So you must have u and you must have the dv. U is equal to negative x. Our dv is equal to cos and x. So for u here, you have to differentiate until you get 0. So negative x differentiate for the first time will become negative 1. Differentiate negative 1 will become 0. So we want to integrate. So we will move from the column I to the column D. So integrate cos will become positive sign. So this one will become sin nx. And then we have to differentiate the argument and write at the bottom side. So differentiate nx with respect to x. So will become n. Divide with n. So now integrate sin nx over n. Integrate sin. If you integrate negative sign, your answer will become positive cos. So we want to integrate positive sign. So means that you have to move the negative to the other side. So your answer will become negative cos. Negative cos nx divide with n the power of 2. So why we have n the power of 2 here? Because at the upper side here we have n, and then we differentiate one more time the argument here. So that's why this one will become n squared. So now how to join your answer? We have to cross multiply the first layer with the second layer, the second layer with the third layer. the first error with the positive sign, negative sign. So write back our answer. So from here we have 2 over pi. So therefore our AN is equal to 2 over pi. In this big bracket we will write the answer for the tabular method. Negative x multiply with the sign nx over n with the positive sign. So negative positive will become negative. Negative. X multiply with the sign nx over n. X sign nx over n. Negative with the negative will become positive. Positive with the negative will become negative. Negative. 1 multiply with the cos nx over n square will become cos nx over n square. So your limit is from 0 until pi. So now substitute the limit. Substitute pi into the position of x. 2 over pi. Substitute pi to the position of x here will become negative pi sin n pi divide with n minus cos n pi divide with n square. Close the bracket minus. So now substitute the second limit to the position of x. So 0 multiply with the sign. So everything will become 0. 0. Substitute 0 to the position of nx here. Cos n multiply 0 will become cos 0. Minus cos 0 divide with n square. So close the whole thing. So now we have to simplify the answer. Sin n pi, this one you have to refer to the table. Sin n pi is equal to 0. So this one automatic will become 0. Cos n pi, this one if you refer to the formula here, cos n pi is equal to negative 1 the power of n. So this one will become negative 1 the power of n. Cos of 0, by using your calculator, cos of 0 will become 1. So rewrite back your answer. AN will become 2 over pi. Negative pi multiply with 0, everything will become 0. Minus negative 1 the power of n divide with n square. Negative 1 the power of n divide with n square. Minus 0, so it's minus 0. Minus will become plus 1 over n the power of 2. So therefore our final answer will become 2 over n square pi negative 1 the power of n plus 1. So I bring n square to the front here because we have n square for both terms. So now substitute all the Fourier series coefficient A0, AN and BN into the formula of the Fourier series expansion. So therefore fx is equal to A0 over 2. Our A0 is equal to negative pi. So negative pi over 2 plus summation n equal to 1 until infinity. In this big bracket, AN multiply with the cos. So AN is equal to 2 over n square pi multiply negative 1 the power of n plus 1. 2 over n square pi negative 1 the power of n plus 1. The whole thing must be multiplied with the cos n pi x over L, whereby L is equal to pi. Cos n pi x over pi plus Bn multiply with the sign. Bn is equal to 0. So this one automatic the whole thing will become 0. So now we just rewrite back. Fx is equal to negative pi over 2 plus summation n equal to 1 until infinity. 2 over n square pi negative 1 the power of n plus 1 multiply with the cos and x. n pi x over pi, we can cancel out the pi here. So this one will become nx. So this is the answer for the Fourier series expansion for this example. So if you refer to the final answer that I give in this example, the final answer that I give here is in terms of n plus 1, because I change negative sign become positive. So means that from here, if we want to change negative become positive, so this one will become 2 over n square pi negative 1 n plus 1 plus with 1. Okay, so there is no problem if you want to change it become n plus 1, or you want to remain your final answer as before.